All right. So, before we start, do we have any questions? I know that we missed a week, and it's probably been a while.
Yeah,
I
I'm
didn't
just
even
trying.
know we were having this test. Thanks to my.
Wait, you didn't know?
No.
Is that concussion that bad?
You,
My dad didn't tell me.
oh, oh.
Hope for the best.
Well, I mean, you're gonna be taking it on your own time. You won't be taking it with me. Today we have a few things to talk about that are just sort of like little things that fill in some holes. Um, but let's quickly talk about the test before we start here. Um, it's 10 sections. Each section has like 4 or 5 questions plus an extra credit question. You don't have to answer the extra credit questions, but they can definitely help you.
It's a multiple choice.
Some of it is.
Oh.
You.
Um, it's probably about 65%, 70% multiple choice.
See, I better
So
30%.
Um, very short answer.
Oh, okay.
Writing little lines of code, etc., etc. Nothing extravagant.
what is that?
I
With that, I still have that.
don't even know where it came from.
It's the brownie cookies that we had last time.
Oh. Anyways, so
Keep that in mind.
like I said, you have the option as to whether or not you want to answer the extra credit questions. They can provide you. The test in total, the regular questions is 40 points, but there's like something like 26 points of extra credit questions. So if you do some work on the extra credit and you miss something, um, there's stuff there to help you get caught up. In fact, the last extra credit question is worth a total of 7 points, but it is the hardest question on the test.
What is the question? Can you just
No.
Well, we won't look at the test here just yet. I'm going to post it in the group chat after we're done here. But the rules for the test are you can use any resource, Google, the videos, whatever you can find, except for me. You cannot ask me any questions about the test.
That could get really annoying. What's this thing that you told us already that I didn't pay attention to?
If you have a question about the way something is worded, then obviously that's fine to ask me. I did have somebody take the test who has a very basic general knowledge of Java. He's not watched any of the videos, and he never really got much beyond if statements when he was trying to learn. So he only ended up getting like a 30 out of 100 on the test. What?
Was it Delson?
No, it wasn't Delson. Yes, it was Mrs. Klein. No, it was Jeffrey Fodder. I had him take it for me just to make sure that everything was worded legibly. But I will say this. I would rather you try to get the answer to a question than do what Jeffrey did and just put a bunch of periods in the answer box or pick a random answer from a multiple choice. You guys have Google. You guys have the videos and any other resource. You want to go to the library and check out a book on Java?
There's books on Java? I'll get one of them. That's gonna help.
Okay. Yes, there are books on Java. There are books on every programming language. In fact, one of the tabs that I have open right now, the Humble Bundle, the Humble Book Bundle actually this week, is a collection of books about different programming languages. JavaScript, Haskell, Clojure. Yes, there are books on programming languages. In fact, that's how I learned C++, is I bought C++ for Dummies from Barnes & Noble and read the whole thing. So, just in general, like I said, I would rather you guys answer the question with a meaningful attempt and get it wrong than don't answer the question at all and, me having no idea, where you might be missing something. Because the difference between some answers on the questions is only one character. Like it's missing a semicolon or something is written incorrectly, or something is capitalized when it shouldn't be. So it's something that you guys are going to have to watch out for. I will say this, one thing about Google Forms that they don't do particularly well on notifying you of is watch out for questions that might have multiple answers. If it's a circle to select it, it only has one answer. If it's squares, it might have more than one answer. In fact, it will always have more than one answer if I use the squares. Okay? Does that make sense?
Yeah.
Before we move on to something else. Okay. So today is going to be a lot of bits and pieces. And in fact, there's one thing that we're going to talk about that we won't even be writing any code for. I just want to talk about it before we get into robot programming, because some of the things that we've talked about doing will require the concept that I'll be talking about. It's not a particularly hard concept. In fact, it's probably what we're going to be talking about first. But it will be nice for me to give an introduction before we sit down and talk about the RoboRio in general, different types of hardware signaling, and stuff like that. That way, when we sit down and look at a practical problem to try to make use of that, then you'll already have the foundations there to move on to the next step. I will say this, one thing that I forgot to mention about the test, nobody sees your answers but me. I'm going to message you privately in some way, shape, or form, either through your email or on Facebook. And we're going to quickly go over, where there might be holes in your knowledge and stuff, and this will be more of a mechanism for me to know what I might want to go over before we move on to the RoboRio stuff and robot stuff specifically. One thing that I lost my train. Well, either way, we will be talking about it individually, and then once I have a general idea of where people are at, then we'll go from there. If there's something that collectively you guys aren't getting, then we'll go over it again in a different way or something. I don't know if Anthony's actually watching this, and if somebody's watching this later that joins the team later, if you take the test once it's released, which it will also be in the description of this video, a link to it, you just have to let me know that you've taken it, because I won't actively check it after like the next week and a half. So you just have to tell me that you took it, and I'll grade it and deal with it then. So the first thing we're going to talk about very quickly, which won't require any code, is we're going to talk about the basics of threading. Now, does anybody know what a thread is? Well, that's like the fabric definition, like a thread in a shirt. Threading in programming is a little bit different. But you probably all have heard of the concept called multitasking, where something is doing more than one thing at any given time. So, as a human being, I can sit here and pat my head and rub my tummy, and it works out fine, okay? And I can do this at the same time because human brains can do things in parallel. You can be doing one thing and the other at the same time, okay? But imagine if we weren't parallel beings. Like Tyler, right now you're listening to me and taking notes. What if you had to listen to me and then take notes? I'd have to stop talking while you're taking notes so you could keep listening.
Yes.
Is that very efficient?
No.
Okay, perfect. So the concept is there. The concept of threading in computers relates to how a computer multitasks. I'm going to ask you two a question, and there is only one right answer to this. Can a computer do two things or more simultaneously?
Well, yeah.
I'm gonna say yes.
The answer is kinda.
Because look, ready? I got Java open.
Okay, but hang on. I'm going to explain why it's kinda. rather than yes. A computer does things sequentially, like what I was just talking about with Tyler.
Wait, what does consequentially mean? I can't.
Sequentially?
Yeah.
It just means to do something one after the other, after the other, after the other.
Okay.
Rather than doing it at the same time in parallel, you do something step by step by step by step. Okay?
It means like you put the peanut butter on, you put the jelly on, you're not instead of pouring the peanut
You don't
butter
have
on
two
the
knives
jelly.
right in the jars and going like this. So, a computer does things sequentially, for the most part. There are some computers that can do things closer to parallel, but it's still not perfectly parallel. Most computers just do things sequentially. But computers do this very, very fast, to the point where you can't even comprehend the speed at which it does it. So what it does is it takes two tasks which are different, does something in one, does something in the next, does something in one, does something in the next, does something in one, does something in the next, really, 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 really fast. And it makes it seem like your computer is doing more than one thing at the same time. But in all actuality, it's not. So this is where the concept of threading comes in, and Justin's comment about a fabric of thread is where I believe actually the term comes from, is it's like little pieces of thread right next to each other running in sequence.
Yeah.
Okay? So in every programming language there's a way to do threading, and I'm not going to show you an example of it today simply because it goes into some concepts that I'm not ready to talk about. Specifically, computers have when computers were initially designed, nobody really thought we'd be doing more than one thing at a time. We'd always be picking something that we wanted to work on, a mathematical function, a model, something that we were trying to work on specifically that we could break down into a step-by-step process and work on it on one machine right straight through until it was done. Nobody ever really suspected that we would have computers that can, have 30 some odd programs open and still run fine. So processors in of themselves really aren't designed to handle doing things at the same time, which is why most processors aren't truly parallel. And the reason why this is, for the most part, is there's a bit of an issue with the way memory is shared. So, if I told you to think of something, think of anything that you could write in your notebook without offending someone.
A potato.
Now, if I were to have you write to that page and have me try to read it at the same time, does that work?
No.
No. And it's the same problem with computers. Let's say you have one thread running, and it's trying to write to a certain spot in memory. But you have another thread running in the same space, and it's trying to look at that spot in memory and read a value from it. So someone's trying to change it while you're trying to look at it. Does that seem very efficient? No. So that's one of the reasons why I won't be going very deep into threading today. I just wanted to give you like a little sampler piece on it because it's something that will need to be talked about, and if you guys have a general understanding right now, then that's good. It's just we're going to go over it again in more detail once we get closer. But for the moment, just know that it's there, and it will be something that we'll be using simply because we're going to have to get something down. If we do, determining where we are based on an accelerometer and a gyroscope, if we do stuff based on, the distance from a wall from an ultrasonic sensor, it's going to be one of those things where we're going to want something to be running at a particular speed, and it has to be a relatively accurate speed.
You determine how fast something's running?
Well, yes, actually, I just did that the other day with a piece of code that I ran on my RoboRio. The RoboRio has about a 2.6 millisecond variance over 15 seconds if you tell something to delay every 20 milliseconds, I found. So it's not that much. It's almost negligible. Almost, mind you. Almost negligible. But that's all I'm going to talk about on threading today. The next thing that I'm going to talk about is ArrayList and wrapper classes. Now, we saw how to do stuff with let me see, I gotta find ArrayList demo. This goes back to the whole thing where I can't talk and type and work at the same time.
You can't multitask?
Yes, exactly. I cannot always multitask, especially when I'm trying to do something like this. So we saw how to do arrays a little while back. I think it was probably 2-3 weeks back now, something like that. ArrayList is just another way of creating an array in Java, but it provides a lot more features than your standard array. Specifically, it can be dynamically sized, which means that you don't have to tell it what size you want it to be. It will just keep growing to fit the amount of data that you provide to it. Okay?
Yeah.
Yes? Okay. You can also remove elements entirely from the array and shrink the array down by 1 once you remove that element. So rather than having...
Is an element like one line?
An element would be like one variable in the array.
Okay.
So when I reference something when I say element, I mean a certain variable in that array. So like if I say element 0, then I mean the first variable in the array. Okay? And you can use that terminology with regular arrays too. If you say I want element 2 of that array, then someone's going to know, okay, you want element 2 of that array. Now, one of the downfalls of ArrayList is, you remember how we talked about primitive types and how they're a little bit different from objects?
Yeah.
Yes. Like int, double, boolean.
Yeah.
I have it written down.
ArrayList cannot store primitive types. However, it can store the wrapper classes for each of the primitive types. A wrapper class is just a way that Java takes a primitive type and turns it into an object to make it so that it's usable with things like ArrayList.
So it can store things that can be turned into an object?
Yes. So each of the primitive types has its own wrapper class, so that if you're using it with something like ArrayList, you can store it. So what we're going to do is I'm going to create public static void main string array args. Oops. So if you remember when we saw comparable, ArrayList is templated, which means that you have to tell it what type it has to accept before you can use it. In this case, I'm going to give it the wrapper class integer. Okay? So whenever you have a primitive type, it's always going to be whatever it is, like int is an integer, with a capital letter at the beginning of it. So like double is just double with a capital letter at the beginning of it. Boolean is just boolean with a capital B at the beginning of it. Blah, 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 blah. If I could stop spelling integer, that'd be helpful. 5122. So, So we create a new array list called array, which stores integers. Okay? Now, ArrayList is found in java.util.ArrayList, and you do need to call an import statement if you're going to use ArrayList. It's just like scanner, where scanner is import java.util.scanner, if you remember. Yes?
So there's one thing that I like in Java is one of us. It was like instead of doing that, you do java.util and then you do dot or
the asterisk.
Yeah, that's like instead of
okay.
Like wildcard or something.
Yes, that's called a wildcard import. Very good. I don't like it when programmers use wildcard imports wildly. And I know that sounds a little weird. If you are using a wildcard import because you are importing every class from a package, fine. Like, let's say you had a package that has classes A, B, and C in it, and you make use of A, B, and C in the code that you're working on. That would be acceptable to use a wildcard import. However, with things like java.util, I think there's something like 20 classes in java.util and something like 10 interfaces. So using a wildcard import is completely unnecessary and can actually make your program a little bigger than it needs to be, depending on how your compiler is set up. So, I am going to advise against you using wildcard imports. And if you use wildcard imports when you're doing robot programming, I will make you go back and I will make you import things the correct way, because there is no reason to wildcard import anything from the WPI library. You will never use every class from one of the packages in the WPI library, ever. I've never even had a reason to do it, and I've done a lot of robot programming. So, but wildcard imports aside, so now what we can do is we can add some stuff to our array. So array.add, which if you look, when we template something like this with integer, it will tell you in the little tooltip section that it's now of type integer that you have to add to it. If you look there, see?
Oh yeah.
So you have to add an integer. Here, look. Yeah. So one thing that we can do is we can say new integer, and then I'm just going to put a random one in there. I think I'm going to put 14. And then I'm going to put array. I'm going to do this a few times just with some, oops. You'll notice that if you use the quick complete, it will always use add all. This is because of the way Eclipse does things, and it's very annoying. It assumes that you want add all for some reason. So I've added 3 elements to the array. Now, because in the parentheses I didn't tell it how big I wanted the array to be, it starts off as like a size of 0, if I remember correctly. And each time you add something, it will add a little bit more space so you can add something else. But right now, our array's size should be 3. But let's see how this works here. Yes. Let's do that. System.out.println array.size. So if we run this just to have a look-see here, we print a 3, which my console output is not as big as it should be. So we have an array of size 3. Now, of course, because integer is a class, somebody's implemented a toString method for it. So if we use for int I equals 0, I is less than array.size I++ system.out.println. Now the way you get elements from an array list is you have to use the get method, because the brackets that we saw with regular arrays don't actually do anything. In fact, you'll get an error. Okay? Yes? Yes? Okay. So, get I. So then we can run this again, and we'll see it print. We'll see it print our size and our 3 numbers in the order that we added them. Now, ArrayList has oodles and oodles. Let's see if I can't. If Bandicam would stop being so. So this is something called a JavaDoc. The entire Java library and 99.99% of the Java libraries you come across will always have a JavaDoc associated with it, describing the features of every class, every interface, everything in that library. Okay? These are your go-to resource to understand what a class does and how to use it. They'll often have really well written out descriptions, and they'll have information about all of the interfaces, the subclasses, and the superclasses that it makes use of, and all of the methods, constructors that you could ever possibly need to know about that class will be in these. There is an entire JavaDoc for the entire Java programming language. You want to know about some random backwater class buried deep into Java? It's in here somewhere.
Wait, how do you get to that?
Well, what I did was I looked up ArrayList JavaDoc. If you look up the name of a class and then JavaDoc afterwards, it will be the first or second Google result. If you just look up JavaDoc, that will bring up the whole thing. But let me just show you. So this is Java's entire packet tree that I'm about to scroll through. This is all stuff that's built into Java. I'm only halfway done.
Quick question. Can you do Java.wildcard and do all of that?
You can technically wildcard. Well, there's multiple header, sort of. I'll answer that with sort of, because some packages built into the Java language start with org, some start with Java, some start with JavaX, and I believe there's a fourth one, but I've never had to use it. But yes, you could technically wildcard in all of Java. However, your compiler is not stupid, and it will not try to compile and dex. It's called dexing, just a shorter term for indexing. It will not try to dex all of those libraries in together and try to make a functional program out of it, because it knows that you haven't used anything from any of those classes, and it will only put the information in that it's been imported. It may take a few seconds longer than compiling like a blank program, but it's not going to take very long. And it's not going to create a big program either. It might be a kilobyte or two bigger. But, so, do you guys want anything more on ArrayList? Is there anything, I mean, you can do this with doubles, you can do this with booleans, you can do this with shorts, longs, chars. What's the 7th one? I can't remember. Byte. You can do it with bytes. I mean, if you guys are all set, this is a very general overview. And like I said, you want to know more about ArrayList? Go read ArrayList JavaDoc. You just Google ArrayList and then JavaDoc, and it's all right there. And that's going to be a lot of how you learn how to use something in Java, is by reading JavaDocs. The other day, what was I doing? I wanted to do something. I think I wanted to have... Oh, I remember what I was doing. So, Google Images, right? I sifted through the page code for Google Images, and I wrote a piece to a program that I'm creating. It's designed to retag MP3 files for you. Like change the artist name, change the album artwork, etc., etc. I wrote, using the information that I had gathered from Java docs about how to access web pages in Java, I wrote a program that went to Google Images, searched a certain text string, ripped the page apart, and pulled out only the image URLs so I could load them in my program.
And you didn't have to do anything. You didn't have to do it yourself. It did it by itself.
Yeah, I typed in what I wanted it to search and then pushed enter, and it ripped apart the page for me and just gave me the URLs.
Wow, that's cool.
So, I mean, and that was all just, I sat down, I read Java docs, there was a couple of things that I had to look up online, but if you've got a particular question about an error or something, normally, if you Google it, it will pop up for you, and will give you at least a little bit of insight so you can start playing with something to try to make it work a little bit better. And if we get the chance towards the end of this, I don't really have a whole lot of content today, so if we get the chance towards the end of this, I may actually be able to show you that piece of the program. The program itself is called JTagger, but we'll see towards the end. It is in this, I think it's in this one, I think. Yep, it is. So we'll see if we get to that. I need to remember what I actually wanted to do today. Threading basics, wrapper class, the array list class, math, random, and static members. Okay, so this is actually going to be a little bit more useful than I thought it was going to be. We're going to make use of another class from util called random. Random does basically what it says. It generates things that are random. Now, one thing that I want to say about random is something that's inherent to all computers. No computer is truly random, because it can't be. Everything has to be broken down to a process somewhere. Like, it wouldn't make any sense if a computer just randomly worked. You can't make all those little circuits just work together randomly. Does that make sense?
Yeah.
So, you have to go through some sort of process to make a random number. So the random class, and any random classes that branch off of it, are pseudo-random, meaning that they generate seemingly random numbers, but they're not really random. In fact, if you took enough samples, i.e. you asked for enough random numbers, you would get a uniform distribution. That means that for each number, you'd get it the same number of times. So if you did numbers between 1 and 5, inclusive on each end, so with 1 and 5, and you sampled 100,000 times, you'd have roughly a straight line across.
Straight line of what? Just numbers?
Like, no, you'd have the same number of 1s, the same number of 2s, the same number of 3s, the same number of 4, the same number of 5. Okay? So there are a couple of classes in Java, one of them secure random, that can sort of circumvent this, but anything that is generated randomly by a computer isn't going to be truly random. It's just not. There was a little device that came out. It was a little USB device that came out. It was a few months ago now, probably towards the beginning of the year actually, that is technically truly random because it uses a characteristic of electricity to generate electrical noise, and then a sensor reads that electrical noise to create random numbers.
Yeah.
So that would be truly random, unless there's something about physics that we don't know.
Probably, yes.
Probably. Somebody's going to sit down with that device someday and be like, I'm going to take 100 billion samples of this, and it's going to come out as a uniform distribution, everyone's going to crap their pants.
Yeah.
So let's delve right in. We'll actually use this to make some random numbers. So the way we create a new random is we say random, and I'm just going to call it rand, equals new random. And we're going to have to import it like with ArrayList, which is just java.util.random. And then what we're going to do is we're going to call rand.nextInt. And nextInt takes an argument that determines how far you want to go down the line. Now, it goes from 0 to 1 less than what you tell it. So 0 inclusive, and then the ending number exclusive. Okay? So if I say 10, what are the numbers that I can have?
9.
0 through 9. Okay. So that's what we're going to do, actually, for all of them. It's rand.nextInt 10. Rand.nextInt 10. So now we're going to run this a couple times here. Wherever it went. So this time we got 407. And the next time we got 155. So still the same number of numbers in the array, just random. So does random make sense? Do I need to talk about that anymore?
No, that makes sense.
Okay. I'm going to stand up for a minute, so I'm going to pause the video. My back is not liking this chair. I'm going to have to move. So we will be back. Okay, so we're back. We're all caught up. I've moved seats. We have 2 things left to talk about. Math. The math class. We're not going to talk about the math that we talked about earlier again. Let's not do that. We're going to talk about the math class, and we're going to talk about something called static members. The first thing that we're going to talk about is math, because it's the easiest of the two. I need to find, and we're actually going to go back to a Java doc for this one. Math Java doc. So the math class provides functions in Java to do things that don't have a symbol to do them. Like, you know how if you want to use multiplication, you just use an asterisk. If you want to do division, you just use a /, etc., etc. What?
Square roots and stuff, is that like that?
Square roots and stuff is what's in math. So,
I can teach Java to do my math.
Dude.
so the math class has a lot of different stuff available to you. It's got absolute value, cosine, sine, and tangent, the cube root of a value. If you have a decimal value, you can round, get the ceiling or the floor of the value. Well, no, your calculator can do all this. Do you guys know what ceiling and floor is?
No.
So round uses the 4-5 rule. You guys know the 4-5 rule, where if it's less than 5, it goes down. If it's 5 or more, it goes up.
Oh, yeah.
Ceiling just means if it's a decimal, it always goes up, and floor just means if it's a decimal, it always goes down.
Wait, how does it go up and down to the down if it's a decimal?
No. Listen. If you take a decimal like 4.3.
Oh, it's less than 0.5.
It's like saying
Yeah.
it's something you'd use if you're like talking about people. You can't have like
Yeah, you
5, 6 people.
Yes, you have to have either 5 or 4 people.
Okay.
Like you can't
So
have
you're always bound.
you can't have 0.56 of a person. So ceiling, what it does is if you had 0.56, it would always go to 5.
Yeah.
So 4.56 would always be 5 if you ceilinged it. But if you used floor, then 4.56 would always be 4. Okay? Yeah?
Yeah.
Let's see. And there's all kinds of other stuff in here. Log. The max and min of 2 different numbers, so whichever one is bigger or smaller. Power. There's also a random method in math, but nobody ever uses it.
Unless you're that one guy.
Unless you're that one guy. You can convert from degrees to radians, etc., etc. There's also a predefined value called pi in here that is an extremely accurate representation of pi, down to 17 decimal places, I believe, if I remember correctly. So, circle math, you can do it with that. There's also E, the constant value E in here. It's 2.1 something or other. But this is how you would do math, like square roots, powers, stuff like that, easily. Do you guys want a demonstration? I mean, I don't know what I would really demonstrate. Actually, I know what I could show you guys.
Could you make a program for a school where if you say you're trying to find x, you put in 2 numbers or how many other numbers there are, could it find x for you?
So, yes, it could find x for you. You could write function solvers in Java. In fact, there's a whole library called Apache Commons Math, which is literally designed to do just that. In fact, I've used it before. I gave it a 6th order polynomial function, which means that the highest power was a 6, so it was something, 10x to the 6 plus blah 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 blah, and it solved it in seconds.
You need to teach me how to do that.
But it's one of those things where you have to have a way of checking to make sure that you're doing it right in the code. Like, I checked it with my calculator afterwards, and I was right. But it took my calculator significantly longer. It took my calculator like 15 seconds to solve that problem. I have a TI-89 titanium. But yes, it is possible to do stuff like that. It's not possible to do it with just the generic math class, at least not easily. But with things like Apache Commons Math, you could do it. Put the lint roller down. So let me find a little piece of code to show you guys here. This is my version of the code that...
It's like all you do on your free time.
No, I play games too. Watch YouTube. Oh, for God's sake.
That's my life. Do you even sleep?
So, like, there's an example of me using cosine and sine. Here's a really long equation where I calculate the cumulative displacement across several moments using a displacement formula from physics, which is just the initial velocity times the period of time that has passed, plus a half times the current acceleration times the period to the power of 2. Wait until you guys take physics. This is what they teach you in the first 2 or 3 weeks of physics.
Yeah, I've seen that before.
You've seen that before? Good. Good.
Welcoming to physics. It's like Newton's like second law.
No, the second law is
like force and stuff.
yeah. This is just a displacement formula. There's all kinds of these for various situations. I think you might be thinking of the conserved force equation and how you determine whether or not something is accelerating or not, whether or not it's got the same amount of force in either direction, and if it doesn't, then that means it's accelerating. I don't know, it's been a while since I took physics, and well, I got a really good grade. I haven't had any reason to use it other than this, and this is just basics. So,
I use physics every day.
But anyways, so this is just a very quick example of how a math method might be used. Now, math is actually a really good way to talk about today's final topic that's going to be new material, and that's static members. A static member is an element to a class that does not require you to create an object to use it. Okay? I'm looking to you, Justin, right now because Tyler's writing.
An element to a class.
It's an element to a class that does not require an object to be created in order to use it.
So it's pretty much just the override button sort of deal.
Well, the best way to describe it is to make use of all of the math methods. Does the math class really need to have characteristics in order to be able to perform like the power operation? Or could you just hand those into a method and produce the same result much quicker? Like, would it make sense if you had to create a new object of the math class every single time you wanted to call the power function?
No.
So that's where static members come in. They make it so that things that are inherently simple, that may not need to have an object associated with it, but still need to be there for programmers to use, can be somewhere. In fact, we see static methods, or a static method, every time we create a main class. Public static void main string args. So let's go back to ArrayList main and I'll show you what I'm talking about. So this keyword static just makes it so that whatever you're creating doesn't need an object to be created in order for it to be used. And this is actually how Java runs your program. Is it looks at your class and it looks for this method and says, okay, this is what I'm going to run. It wouldn't be particularly easy for Java to run your program if it had to create an object that might take values or might not, and then have to call a method from that object in order to get your program to run. It's very redundant and isn't really necessary. So that's why static is there. It makes it so that you don't have to create something that isn't even useful in order to perform an action. Now, there is such a thing as a static variable, where you reference it by accessing it from the class name. And the way you would do something like that is you would say public static final int and then some value equals 10. So what I've just done is I've created a static value that can be accessed by saying ArrayList main dot some value equals 10. And let me rephrase that. ArrayList main dot some value, and it will return a value of 10. Okay? Now we have the public modifier, so anybody can get at it. Static, so that you can use it without creating an object based on ArrayList main. Okay? Yes?
Yes.
You okay? Okay. final, which just means that whatever we store in this cannot change. If you ever want something to be a constant, you don't ever want it to be able to be changed, then you put the final keyword in there, and you won't be able to change it.
What if that's what if you put in a mistake and you go back, or is it just there?
Well, here's the thing.
In the code, but the code can't change it.
The code can't change it. Justin is exactly right. You can change it in the code. Like if I wanted this to be 20, it's 20 now.
Oh, okay.
But the code, while it's running, cannot change it. And if you try to, Eclipse will be like, are you stupid?
You do like array list names dot some value, and you do plus 20. It's not gonna do 40. It's just gonna be all messed up, right?
Well, actually, no. You can still do math with that value, so long as you don't try to store a new value in some value. Does that make sense?
Yeah.
So, like, if I say some value equals some value plus 20, will that work? Correct. But if I say new value equals some value plus 20, will that work?
Yes.
Yes. Perfect. Okay. So, and of course, just to show you, we'll add a little something here. Array.add, son of a, new integer array list main dot some value. Now, because we're in the same class as where we're using it, where it's been created, we don't actually have to do it this way. Like, we could do it this way, and it would still compile fine. But this was just to show you how it works. Okay? So that's how, if you were using it in a different class, you would reference it, is you'd have to say ArrayListMain.SomeValue. Okay? Yes?
Yes.
I hope I'm not annoying you guys with the okay, yes stuff. I just want to make sure you get it. Because if I move on and add stuff to it, oh my god. It's just going to be a train wreck. Anyways, so let's just make sure this works. Just as a little demonstrative piece. Oh my god, I keep moving stuff around. So 683 and then 20. And if we run it again, 27720. Okay? Alright, so we're going to take another quick pause here. Before we talk about the practical assignment real quick, which what I talk about in the practical about the practical assignment won't necessarily be final, but it will be relatively close to final, probably 95% or so. Oh, I've lost my train again. But before we do that, I'm going to show you guys that little snippet of code that I was talking about earlier about how you can find image URLs in Java. I think I've still got it somewhere nearby here. Let me see if I can pull it up. But we are going to pause for just a second. Alright, so we're back, sort of. I didn't find the code that I was looking for. I don't know where it is. So I can't show the thing that actually grabs all of the pictures without writing it again, but I can show you JTagger pretty easily. Run Java. So this is sort of what JTagger looks like. It had some spacing issues that I never really worked out because I haven't worked on it in forever. What?
You're gonna get arrested for putting this on.
No, because it doesn't even really work. I think it worked once, and then I never finished it. But I can open up, let me go to my music. I know that there's one song in one of these folders here somewhere. It's this one. And then, which is supposed to load the first file. Open. And then, so, this was one that I actually did do by a group called Cash Cash. I put their artwork in. I can actually change it from a file if I open it up, but this was a very rough cut version of JTagger, and if I was going to write it again, I actually probably wouldn't write it in Java. Java is a little clunky when it comes to doing interfaces. It's much, much easier to do it in Python, I've come to find. But I could change the image from a file. If I go to my desktop, I know I've got some pictures on there. We'll use the Speed Paints one. Open. And so now if I push save and commit, and then I go and open that music file, it should have changed. I gotta go find it though. Where are you? Properties. Let's see, it won't show you the album art in the properties. I'm going to have to actually open it, which is annoying. What do I want to open it with? I guess VLC, because Groove Music is trash. Audio off. So, yeah.
Cash.
Oh, it didn't change. Oh. Why didn't it change? This is the problem with JTagger. Half the time it didn't work, and I never knew why. But probably need to close JTagger, actually, come to think of it. Yes. Yes. Crap. Oh well. Anyways, that was just a little thing. Apparently VLC caused my recording to pause. So, we're going back at this practical assignment. Thank God I didn't get too far in before I realized that it was paused.
Yeah.
Okay. So the practical assignment. You guys are going to get a piece of documentation that will explain to you exactly what you have to do. It's basically you're creating a model using classes and objects that represent shapes. At least 6. 6 of which will be provided to you with information on what you should have in each one. You can create more. In fact, I encourage you to create more, but you will have to at least have the 6 that I specify. You're going to be provided with a list of classes and interfaces and the methods that they should have in them. You will be provided with a description of what the project is going to be like, obviously, like on that document that I was talking about earlier. You're going to be provided with something called a class hierarchy, which will show you how all of these pieces will connect together with each other, or at least how they should. And you will also be provided with, oh, what was the third thing? Fourth thing? My brain is starting to slow down a little bit. It's a little late for me. Oh, and you'll also be provided with program output and a main class, which will be consistent across everybody that does the project, that your code will have to run with when it's using it. So that means that you're going to be given a main class. You're not going to be creating one on your own power. Your code will have to work with the main class no matter what. Okay? Now, today, just as a general rendition, I'm not going to I have written the shape model assignment myself and put in comments and how, in general, I would want it to look. Obviously, yours is not going to look exactly the same as mine, and I don't expect it to. The thing that I'm concerned about is whether or not you can demonstrate the skills that we've talked about in practice, and whether or not you show some level of effort to actually do what is assigned to you. Because when it comes to build season, and you have 6 weeks to complete a robot, you've got to be able to do something correctly and quickly and make sure that you have enough time to leave yourself so that you can debug the program and make it the best that it can be before you end up at a competition. So let me pull open actually it's down here. There it is. Oops. Okay. So the way this works is the main program will generate a random number between 1 and 20. That is the number of shapes that it will add to an array list. The program will then start to create whatever number of shapes it decides. It will pick a number between 0 and 5 inclusive on each end, and those values will either represent a rectangle, a circle, a triangle, a 3D rectangle, or a rectangular prism, a sphere, or a right rectangular pyramid. Sorry, I had to stop, make sure I didn't swallow my tongue on that one. And it will provide specific information to each one of those things in order to function normally, okay? Which will be outlined in the document that you get. Once the shape generation is done, it will begin printing information about each of the shapes stored in the array list. It will first print the shape number. It'll be a number between 0, inclusive, and the number of shapes that it decided on making, exclusive. So if you told it to create 20 shapes, then the number will be between 0 and 19. Okay? It will print the shape's general name. So if it's a triangle, then it will print the word shape. It will print the word shape type and then triangle. It will call the shape's toString method just to get general information about, you know, if it's a rectangle, then what is the length of this rectangle? What is the width of this rectangle, etc. And then it will print the shape's area. If it's a 2D shape, it will print the area. If it's a 3D shape, it will print the surface area. Okay? And then lastly, if it's a 3D shape, it will also print the volume of that shape. Okay? And then it just prints a blank space to space it out a little bit. So let me just show you a little bit of a sample here of its execution. So shape 0, the shape type is a triangle. The triangle had a base of 6.8675. Oh my god, 8675. 8675309. Oh my god, if it had said 309, I would have probably pissed myself. And it had a height of 15.2647. And then it prints the area. And it does this. Oh, I have a little bit of a mistake in my shape volume there. I'll have to fix. See, that's why I said 95%. Because there's some little things here. But you can see that it did what is 15 shapes. And in fact, I think I'm going to change something a little bit here, just so that when it prints the shape number, it prints it 1 through whatever number of shapes that you have, rather than printing the actual iterator number, which starts at 0. There we go. And then we're going to add this. So this is what your main class for that project is going to look like, and what your code is going to have to mesh with in order for you to pass, so to speak. Nothing. Nothing will happen if you don't pass. There is really, with each of these assignments, both the test and the practical assignment, there is no passing grade.
Can I get this as a credit?
That's Mr. Klein is actually working on that, and I'm actually very pleased that he's working on that. If there's one thing that I found truly ridiculous about Messalonsky and their support of their robotics team, is that with all of the stuff that the team does and all of the stuff that we have to learn and do during build season and in the off season, the fact that the students don't get something of a credit, even if it's just a general credit. It doesn't even have to be typed. I feel like they should get something. So I'm desperately hoping that Lawrence will just be like, sure, whatever. They get a credit or a credit and a half or 2 credits because it's year round.
If it's like pretty big, if it's a lot of credits, then like a lot of people will try to join if you know you're not good.
And that's the other thing is you'll either create incentive to join the team because it will fulfill some requirement of graduation, math, science, something, or it will just attract people because they want the general extra credit to show off. I don't know. I've met people like that that just take erroneous amounts of credit, just like, well, mostly in college, but they just take huge number of credit hours, like 16, 17 or more, as opposed to like the standard 12 to 15, because they just want to be the smart one and have no social life at all.
Being social is boring. I'm kidding.
So, there's really not much else to talk about this right now. I'm not going to go into it very much. What I might do, actually, because this video is ending so early, is I might actually have you guys start on the test. Because the test, even if you had to look up every question, I couldn't imagine it's going to take you more than an hour. And I don't suspect that you'll have to look up every question. One of them, all it is do you know your order of operations? I hope to God you do. Otherwise, you and I are going to have a sit down and talk.
Actually, I think about it for a second.
I mean, thinking about it's fine, but, you know, if we get into one of those Facebook arguments about whether or not something is one number or the other, I'm going to be pretty upset, because I wrote the question so that there was only one answer to it. So, we're going to stop the video. This is all that we're going to do for today in terms of new content and talking about stuff that's relevant to everyone's knowledge. I'm going to get Tyler set up with the computer that I brought for him, and I'm going to get Justin at the very least started on the test if he's ready. He's not giving me a ready look. He's giving me like this.
I'll go home and watch the videos 15 times over and then I'll talk.
Okay.
Yeah.
I mean, you do have Google. Google's probably going to be faster than watching the videos.
Yeah. I'm going to do like Google what you told me to.
Yeah.
Atlas, anything, right?
Array list.
My brain's kind of slow today.
That's fine.
I only got like 4 hours sleep last night. He's loud.
And you guys can take, you know, if you want to, I'm probably still going to have you guys take the test right now. If you want to take it again later when you can look stuff up, that's fun. I mean, you can look stuff up now. I don't care. But I want to see where you guys are at, and I want to see how well you can sift through information, because a lot of programming, it's impossible for you to know everything there is about programming just from taking a class. Like, you could go to college and you could take every programming class that they offer, all the way through the advanced stuff. You could spend years doing it, get your doctorate in programming, and you still would not have seen everything possible with the programming languages. You would have seen a lot, but you wouldn't have seen every library, you wouldn't have seen every possible way of doing something, and you wouldn't have seen everything that's going to come out in the next 60, 70 or more some odd years before something else ultimately takes over programming and makes the whole process obsolete.
Moore's law makes it hard to keep up with things.
Yes. Although Moore's law is actually ending right now.
Oh, it is?
Yes, which we can talk about off camera. So, video's done. I'm going to get these two set up after we talk a little bit about Moore's law ending. But, yeah.